All right, hello and good morning. I apologize that I'm not in person today, but hopefully this video format works out just fine and all goes smoothly. All right, so today we're going to work on the first part of Module 3. If you can open your textbooks there to follow along. And today we're going to start getting into atoms and molecules. So, Module 1 was all about measurements and units and kind of an introduction to the math that you're going to need for chemistry. And now we actually get into the cool science stuff. So, if you're not a math person and you like biology and all those just fun little facts, you like knowing how stuff works, this module is going to be awesome. And even if you do like math, this module is also awesome. So, first things first, as an introduction, we want to ask ourselves, what is chemistry? What is chemistry? So, the shortest answer I can give for that is chemistry is the study of matter. Chemistry is the study of matter. What is matter? Matter is anything that has mass and takes up space. So, has mass and volume, I should say. So, air is matter, water is matter, tables are matter, your thoughts are not matter, God is not matter, stuff like that. Okay, so chemistry is the study of matter. It exists in a very wide variety of substances, but why? How does that work? Why does matter exist in solid, liquid, gas? How come when you heat up an egg it hardens, but if you heat up, I don't know, plastic, it melts? Why does matter do the things it does? How does matter change from one substance to another? These are things that we are seeking to understand. What just happened? Sorry, it looks like I jumped notes. Those are things we're seeking to understand through chemistry. So, in this conversation of matter and how stuff works, it leads into another question. If I gave you a radio, just a standard radio, you plug into an outlet, it plays music from radio stations. If I gave you a radio and I told you to tell me what it is made of, what would you do? Okay. If I told you to tell me how the radio works, what would you do? Well, you would take the radio apart and you would study each individual component and figure out what each component does to see how all the components interact together to make the radio. So, that's what we're going to get into in this module, where matter, in this case, is the radio. How does matter work? Well, we're going to dive deep into it. So, first, let's highlight early attempts to understand matter. So, there's something called the continuous theory of matter. Continuous theory of matter. So, way back when, people thought substances were composed of long, unbroken blobs of matter. You could break it down as many times as you wanted and still have the same substance. So, trying to think of an example. So, like grass. I'm looking outside, I see grass. If you took a blade of grass, okay, here's my blade of grass, and you chopped it up, now you have two pieces of grass, okay? And the understanding was you could keep chopping up grass, chopping up grass until you get to a tiny, tiny, tiny microscopic piece, and it's still going to be grass. Okay, that's what people thought it was like back in the old days. Around 400 BC, however, the Greek philosopher Democritus was walking on the beach. Okay, he noticed, if you're ever walking on the beach, the sand looks like one continuous blob of matter. Okay, if you look at the sand, or if you look at the beach from just standing on it, it just looks like white or brown. It's just one blob that makes up the beach. However, if you focus on it, if you stick your hands in it and pick it up, there are individual grains that make up the sand. Also, if you study each individual grain, they're not all the same. You'll have a little piece of a shell or a little piece of a rock, depending on where you are. So this idea of sand being little bits of stuff making up matter, this was an idea he had called the discontinuous theory of matter. So we no longer have blobs of matter, we have particles that make up matter. Okay, so continuous theory was blobs, discontinuous is particles. Okay, now this leads us into some progress in understanding matter that came up in the late 1700s. So during that time, there was a scientist named Antoine Lavoisier, considered to be the founder of chemistry, and he developed a theory that stunned the scientific world called the law of mass conservation. This is on page 70 of your books. So the law of mass conservation. This is going to blow everyone's minds. The law of mass conservation states that matter cannot be created or destroyed. It can only change forms. Matter cannot be created or destroyed. It can only change forms. So, if you think about like a fire, you're burning logs in a fire. Here's my excellent picture of logs in a fire pit, and they're burning. Okay, if you're burning logs in a fire, yes, the logs eventually go away, and you have a bunch of ash left over in the fire pit. Well, if you were to lift up, say this is like a portable fire pit, if you lifted it up with the logs in it versus afterwards when the logs are burned, you would notice that it's lighter. So where did the mass go? Well, it got burned up, and the mass of the logs actually went up into the air in the form of water vapor and carbon dioxide, and some of that ash was carried up and away. So that's when you would see sparks going up. That's ash being burnt in the air. Okay. So we have an example 3.1 on page 73 of your books. So example 3.1. So it says a chemist notices that when given enough energy, a certain white powder changes into two different substances, tin and oxygen. A chemist watches 151 grams of powder undergo this change. The chemist easily collects the tin that was formed and measures its mass to be 119 grams. Okay, so we get 119 grams of tin. Unfortunately, the chemist could not collect the oxygen that was formed and therefore could not determine its mass. Use the law of mass conservation to help the chemist determine how much oxygen was made. Okay, so how much oxygen was made? Well, 151 grams minus 119 grams is equal to 32 grams. Okay. So we know if this white powder just made tin and oxygen, and we measured that there are 119 grams of tin, well, the law of mass conservation says we can't lose any of this mass, so the rest of it had to have been oxygen. You got 32 grams of oxygen. All right. Now, continuing this talk on mass conservation. So that white powder we talked about in the example, that white powder was able to decompose into tin and oxygen. Okay, now scientists discovered another compound, or another chunk of matter, whatever you want to call it, iron sulfide. They discovered that 88 grams of iron sulfide decomposes into 56 grams of iron and 32 grams of sulfur. Okay, so 88 grams iron sulfide goes down to 56 grams iron and 32 grams sulfur. However, iron and sulfur cannot decompose further. So remember that radio example that I talked about earlier? Okay. You break the radio down into different components. Okay, so let's say we get down to like the power source of the radio. You just have a wire going into the radio. You can't take up, there are no other components of the wire. The wire is the base component there. So that would be like an element of the radio. In the same case, iron and sulfur are, you can't break them down any further. There's no recipe that makes iron. There's no recipe that makes sulfur. They just exist. They are what's called elements. Elements. All right, so elements, it's any substance that cannot be decomposed into less massive substances. Okay. Now elements, how do we know what all the elements are? Well, they're compiled into the periodic table of elements. Let's see here. Periodic table of elements. I've got it on a page somewhere. I just have to make it come up on the next page. All right. So this right here is the periodic table of elements. I'm sure you've seen this before and maybe heard a few songs on it. So this periodic table has every element listed in it. We've got hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. You are required to memorize this entire table by next week. Just kidding, you are not. But We will have a quiz on the first 36 of them in 2 weeks. And it's not that hard to memorize, and it's very, very, very valuable information. So there is a copy of this on page 75 of your textbook. There is also one in the front cover of your textbook. Something else that would be useful is if you scanned it with your phone and printed it and kept it in like a plastic cover in your binder or laminated it or something, because we will be looking at this a ton moving forward. All right, so the periodic table. There are 112 boxes on here. So right there's box number 112. That tells us that there are 112 elements that exist. 92 of these elements appear naturally, and 20 of them have been manufactured by scientists in a lab. Now, I don't know exactly which ones have been manufactured, so that's my bad. But that's the dealio. And we have this nice little color code here where we have nonmetals, and nonmetals are shown to the right of this jagged line that goes down. Okay, and hydrogen. So jagged line that goes down plus hydrogen over here, those are our nonmetals. And then everything to the left, those are all different kinds of other metals that we'll learn about. But kind of interesting that most of the elements are, in some way, shape, or form, metals. Now, the element abbreviation which appears on the chart is usually either the first or the first two letters of the element's English or Latin name. So here we have hydrogen, there we have helium. This has two letters because they both start with H. Now, over here, Fe, this is iron. So don't confuse iodine. Where's iodine? Oh, iodine's over here. Don't confuse iodine or whatever this is, iridium, with iron, which is Fe. That's why we're going to memorize some of these. Okay. Now, one more thing. We have what's called metalloids. Those are elements that exhibit some metal and some non-metal properties. But we're not going to worry about that right now. Okay. Now, let's talk about compounds. Compounds. Let's see. So a compound, that time Emma got arrested, she got sent to a prison compound. I'm just kidding. She just went to jail. But anyways, compounds, those are substances that can be decomposed into elements by chemical means. Okay, so compounds are substances that can be decomposed into elements by chemical means. Now, we've talked about elements, we've talked about compounds. All matter is either an element or a compound. Matter is an element or a compound. Now, what we won't get into right now, but we'll get into later, is mixtures. So, let's say water. Everyone knows, well, A lot of people know water is H2O. Now, water is a compound made of hydrogen and oxygen. Okay, now let's say you decided to make lemonade. Okay, so to make lemonade, you either buy a powder kit from the store and stir it in and dissolve it, or you could squeeze lemons in there and add some sugar and stuff like that. Now, what you did not do is make a new compound. That is a mixture of water and lemon stuff. Okay, and that behaves different chemically that we'll learn about. Same thing with, I'm looking at my mouse right now for my computer. So it's made up of plastic. It's got like a little metal bearing for the wheel. It's got a cord coming off. Now that mouse is not a compound. It is an object made of several different compounds that make up the mouse. But the mouse itself and the combination of all those things is not the compound. Okay, now we're going to get into a law. The law of definite proportions. And I know as soon as I write down law of definite proportions, you guys are all so excited to hear what that is. It says that the proportion of elements in any compound is always the same. The proportion of elements in any compound is always the same. Now, what on earth does that mean? So let's think about it in terms of recipes. Every compound has a recipe to build it. Talked about water just a second ago. Water is composed of 2 hydrogen atoms and 1 oxygen atom. So it's 2 parts hydrogen, 1 part oxygen. Now, let's say we had cookies. If you had a recipe that made 10 cookies, I'm going to list a recipe that's probably not going to work. But let's say it's 1 egg. Let's see here. No, that's not a circle. I just want to make a circle. Okay. 10 cookies. Okay. We have 1 egg. 1 cup of chocolate chips. Let's say we've got half a cup of flour. Do they usually have twice as many chocolate chips as flour? Okay, let's say we got half a cup of sugar. So we have equal parts flour and sugar. I don't know how this will turn out. But that makes 10 cookies. Now, if you wanted to make 50 cookies, then we would have to multiply all of this by 50, okay? To have the same recipe, the same mixture. You'd have the same proportion of ingredients to each other. What you're not going to do is have 50 eggs and keep 1 cup of chocolate chips. Then all you have is chocolate scrambled eggs. Okay, that's gross. You gotta have 50 chocolate chips, 25 cups flour, and 25 cups of sugar. You gotta maintain all those proportions. Now, let's say you had, let's say you're making your recipe. Say I want to make these 10 cookies. Okay. But, actually, let's look at instead, let's look at all the ingredients. I'm opening the fridge. I want to make cookies. Okay, let's say I have 2 eggs. I have 3 cups of chocolate chips. I have half a cup of flour, and I have 1 cup of sugar. That's everything I have in my house, okay? Now, if I have 2 eggs, well, that tells me I could make 20 cookies. Great. Okay, I have enough chocolate chips to make 20 cookies. I have enough sugar to make 20 cookies. I don't have enough flour. So, I only have enough flour to make 10 cookies. So, what I'm going to do is I'm going to use this flour. I'm going to use the other ingredients that would make the cookie recipe, and then I would just have leftover ingredients. So I would have an egg left over. I'm going to say leftovers over here. I would have an egg left over. I'd have 2 cups chocolate chips left over. All the flour would be used. I'd have half a cup of sugar left. So, flour is the limiting factor there. All right. Let's see here. Looking for an example. Okay. Now let's work an example with chemistry. Example 3.2. This is on page 80 of your book. It says a chemist reacts 15 grams of calcium. 15 grams of calcium and 15 grams of oxygen. This reaction makes 21 grams of compound known as lime. Okay? 21 grams of lime. Not limes, lime. Along with lime, there's also some leftover oxygen. So 21 plus leftover oxygen. If the chemist wants to make 55 grams of lime and have no leftover oxygen or calcium, how much of each element should he use? Okay. So first things first, we got to figure out how much oxygen was used. So it doesn't say anything about leftover calcium, so we can assume all of the calcium was used. So what we're going to do is look at the total mass of our 2 compounds here, which is 30 grams, yields 21 grams of lime plus, well, what's left? 21 plus what equals 30? 9 grams of oxygen. Okay, so we have 9 grams of oxygen left over. So that tells us that we need 15 grams of calcium and 6 grams of oxygen to get 21 grams of lime. Okay, awesome. Now, how do we get 55 grams? Okay, well, if we go back to this cookie recipe, to get from 10 cookies to 50 cookies, what did we multiply by? Well, we multiplied by 5. And then we had to multiply by 5 for all of these. So to find our multiple, okay, let's call our multiple x. What we're looking for is 55 grams. What we know the recipe for is 21 grams. So if you divide those, you get 2.6. Okay, now this is what's called a dimensionless quality. There's no, or quantity, there's no unit to it. We're just multiplying everything by 2.6 to get the right recipe. So for calcium, we would need to multiply 15 by 2.6, and I should know this is 15.0 if we're talking about significant figures. By 2.6 we get 39 grams. And then for oxygen, we would multiply the 6 grams needed times 2.6, and we get 16 grams when rounded to the appropriate significant figure. So 16 grams calcium, 39 grams calcium, 16 grams of oxygen. Alright, so that's the end of this video. Now, just as a reminder, in 2 weeks we have a quiz on the first 36 elements of the periodic table. I would start memorizing that now. What you will need to memorize is the abbreviation and the chemical that it represents. And at the end of this module, there is a list of all of those that you can read off. It's on page 93 of your book. It has the elements in order with the name and the symbol. So you should go all the way to Krypton. Not Superman's planet Krypton, but that's how far you go on the list. So that's it, and that'll be part of your test grade. So that's how that'll be factored in. Anyways, hope this video was helpful.